Smart contract developers are in high demand, drawing one of the highest salaries in the developer community. And now it's never been easier to become a smart contract developer on Algorand. Hello everyone, my name is Chris, and today I'm going to go over how to set up your development environment with AlgoKit, write a simple Algorand smart contract with Beaker and Pyteal, and deploy and call your smart contract using DappFlow, all in only 10 minutes. A quick note before we get started, I'll be using macOS for this tutorial, but I'll leave a link on how to set up your development environment in Windows, along with all the links I mentioned in the description. Also, there are some prerequisites that you need to install before following along this video. The prerequisites are Python 3.10 or higher, pipx, git, and docker. If you want a full walkthrough of installing these prerequisites, you can find the development environment setup videos in the description. Now let's install AlgoKit, the all-in-one development tool for Algorand developers. With AlgoKit, you'll be able to set up your development environment, your project folder, and start building your dream project with only one command. To install AlgoKit, open up your terminal and type in pipx install AlgoKit. This is going to install AlgoKit, and there you go. AlgoKit is installed. Now this command will install AlgoKit globally, so you'll be able to use AlgoKit in any directories. Now to check if AlgoKit installed correctly, let's run AlgoKit -- version. If you see something like this, then congratulations, you're ready to start building on Algorand. Now let's create your project folder with AlgoKit. To do that, simply run AlgoKit init. First, it's going to ask you to select the project template. Now, since we're not writing any production level smart contract code, we're going to select the Playground template. Playground is the perfect template for learning purposes and for playing around with AlgoKit. So I'm going to click enter and choose the Playground template. Then AlgoKit is going to ask you to name your project. Now for this tutorial, I'm going to create a simple calculator application. So I'm going to name it calculator. It's going to start template copy and render. And once that's completed, it's going to ask you to run AlgoKit Bootstrap, which will install all of the dependencies that you need to build Algorand smart contracts. So I'll say yes to that by pressing Y. And it's going to install all of the dependencies. And then it's going to ask you if you want to initialize a Git repository and perform an initial commit. I'll say yes to that as well. Now, once the initialization is completed, AlgoKit is going to check if you have VS Code configuration. And if you do, it's going to automatically launch VS Code for you. Now, if you don't have that configuration or if you use a different editor, don't worry, just open up your editor of your choice and continue from there. Now, when you go inside of your editor, the first thing you want to do is to check if your Python interpreter is using the virtual environment Python interpreter. For VS Code, you can do Command-Shift-P and then click on the Python select interpreter. Then select the Python version with venv on it. Now for this video, I'm going to write a simple calculator application. So let's head to the Playground folder in the Explorer and then create another folder inside of it called calculator. Then inside the calculator folder, let's create a file called calculator.py. Now before we write the smart contract code, we need to import in Beaker and Pyteal. So let's import in Beaker as BK and import in Pyteal as PT. Then let's create our application using Beaker's application class. So we do bk.application and we name it calculator. And I'm going to set the value to the app variable. Now this calculator is a weird calculator. So it only lets you add and doesn't let you do anything else. Now here we have the add method written and it's going to take in two arguments, A and B. And both of these arguments are abi.uint64 type. Then we have a star here, and it's saying that anything on the left side of the star is an argument for this method, and anything right of the star is the output of the method. Now down here in line 7, I'm going to set the add result variable to a.get plus b.get. Now we need to use the get method from Pyteal to get the values of a and b. Now down in line 8, we're going to return an output that is set to the add result variable that we have up here. Now we need to let the application know that this add method exists and that this add method is an external method that the front end can call. So to do that, all we need to do is add the app.external decorator on top of the add method. This is going to register this add method as an external method to the application that we have created up here. Now this calculator has another great feature that stores the latest calculation in the global state of this smart contract. Global state is state that is recorded on the smart contract that is accessible by everyone. To do that, we first need to define a class that will represent all of the states for this smart contract. So I have created a class called myState, and inside the class we have a variable called result, and that is set to bk.globalStateValue pt.tealtype.un64. This is saying this smart contract has one global state value, and that global state has a UN64 type. After you create the state class, you want to instantiate the class here as a second argument and then assign it to the state variable. Now we want to store the latest calculation during the add method call. So I updated the add method slightly. So inside the return, now we created a sequence where inside the sequence, we're going to first set the add result to the result global state that we have created inside the myState class. And then we're going to set the output as the add result. Now, since we wrote a global state, we need a method to read that global state. So here I have defined a read result method. It doesn't take in any arguments, but the output is set to be a UN64 type. This is also an external method, and we have the read-only flag set to true, and this is because this method call is not changing the state of the blockchain, but is only reading the state of the blockchain. Now this read result is simply returning an output that is set to app.state.result, where app.state.result is the way you can retrieve the value that you have recorded inside the result global state. Now let's compile this code, build it, and deploy it on DappFlow. Now to do that, you want to use the build method inside the application class. So here in line 22, I'm doing app.build and assigning that value to the spec variable. And then we're going to export the spec into an artifacts folder. Now let's save this file, open up your terminal, and then go inside to the calculator folder that you created. Inside the calculator folder, run python 3 calculator.py. Now, if we head back over to the Explorer, and if we look inside the calculator folder, now we have an artifacts folder created. And if you open up the artifacts folder, there are 4 files in there, where 2 of the files are Teal source code. Contract.json is the ABI file generated by your contract. An application.json file is an extended ABI generated with Beaker. Now I mentioned Teal source code. Teal is a low-level assembly language that the AVM takes and executes. And then I talked about contract.json file being an ABI file. ABI stands for Application Binary Interface, and basically it's an instruction for the front end or other applications to interact with the smart contract that you've written. An application.json file is also an ABI, but it is an extended version of an ABI. Now let's launch a private Algorand network using AlgoKit. First, make sure you have Docker running in the background. Then, open up your terminal and then type in AlgoKit localnet start. This is going to start your AlgoKit sandbox environment on your computer, and once it's done, you should have a private Algorand blockchain running on your computer. Now let's head over to DappFlow to deploy our smart contract to our private blockchain and interact with our calculator application. To do that, inside your terminal, run AlgoKit explore. Now running AlgoKit explore will open up DappFlow in a web browser. Now inside of DappFlow, first thing you want to do is create a dev wallet. So click Dev Wallets on the left, and then click Create Wallet. This is going to create a test wallet for you that you can play around with. And if you click Dispense, you can get another 100 test algo to play around with. Now let's head over to Connect Wallet, and then connect our Dev Wallet. And now let's head over to Beaker Studio to launch our calculator. Now our calculator app was written with Beaker and PyTeal, and that's why I'm using the Beaker Studio. But if you write your smart contract only with bare PyTeal, head over to ABI Studio and import in the contract.json file to deploy and interact with your smart contract. Now heading back to Beaker Studio, I'm going to press select app, import Beaker app, click file, upload file, head over to your product folder, go into playground folder, and then into calculator folder, artifacts folder. And inside the artifacts folder, make sure you import in application.json file. Now, once you import in the application.json file, you should see that Beaker Studio was able to retrieve the information that this smart contract is called calculator. It has one global state called result, which is a UN64 type. You can see the approval and clear program written here. And down here, you can see the two methods that we have defined inside the calculator app. Beaker Studio was able to get all of these information from the application.json file. And that's the beauty of the ABI. Now let's click Create App to deploy our calculator application to our local private network. Click Create App and then click Create. If you see transaction successful, this means your application was successfully deployed onto your private Algorand blockchain. Now, if you come back down here, let's try calling the add method. Click Execute. I'm going to add 10 plus 5. And if I click Execute, you can see that the value returned 15. Now remember, our calculator is a weird calculator that has a feature that will store the latest calculation in the global state. So let's try calling the read result method to see if our latest calculation was successfully stored in the global state. So click Execute, and let's click Execute here. And you can see that the read result returned value 15, which is the latest calculation that we did from add method. Now let's try adding again with a different value. This time let's add 3 and 4. Now the value should return 7. And if you go back to read result and call this again, you can see that the value is updated and now stores the value 7. This is how you use DappFlow to quickly deploy your smart contract and test out your code. And that's it. Today we covered how to set up your development environment using AlgoKit, how to write a simple Algorand smart contract with Beaker and Pyteal, and how to deploy and call your smart contract using DappFlow. Now this video is too short to cover all of the powerful features of Algorand smart contracts, but stay tuned for complete video series on Pyteal, Beaker, Teal, and other Algorand Layer 1 features and become a master Algorand developer. Hopefully this video has taught you how to start developing on the Algorand blockchain, and I look forward to seeing you build your application on Algorand.